Today we will continue together the electrolysis of aqueous solution of ionic compound. We know that from last recorded session, the electrolysis is a technique used to split compounds into their element by using electricity, where the electric current passing through the electrolytes, so the ions of electrolytes have been free. Insoluble compound as metal oxides, we melted them to change them into liquid or molten form to form electrolyte, but soluble compound as copper sulfate or sodium chloride, we dissolve them in water to form electrolyte. Okay? In electrolysis, we need a beaker that contains electrolyte, as we see, okay? And also we need two electrodes. One of them is known as anode that represents the positive electrode and attached to or connected to the positive pole of the battery, while the other is known as cathode that represents the negative electrode and that connected to the negative pole of battery. And we need the wire to connect the two electrodes to the battery. In aqueous solution of ionic compound, okay, the water ionized into hydrogen positive ions and hydroxide negative ions. Also, the ionic compound ionized into positive ions and the negative ions. So the role of electrolysis, the cathode attract positive ions found during electrolysis, okay, as the metal positive ions and the hydrogen positive ion resulted from water ionization. But cathode will only discharge one type of ion. The ion of the least reactive element will be discharged according to chemical activity series. So the metal ions would be discharged if the metal is less active than hydrogen or follow the hydrogen in chemical activity series. At anode, the positive electrode have the same problem, where anode attract negative ions, but if the negative ion is halogen, the halogen will be discharged, okay? Halogen like fluorine, chlorine, bromine, iodine. But if the negative ion isn't halogen, always hydroxide, negative ion resulted from ionization of water will be discharged, okay? So let's start with the first example, electrolysis of dilute sulfuric acid. Sulfuric acid, its chemical formula H2SO4. So the ion present hydrogen positive ion, sulfate negative ion, hydroxide negative ion. Cathodic reaction at cathode. What happened? Hydrogen positive ions are attracted to the cathode, okay? So at cathode, it will reduce by gaining electrons and change into hydrogen gas, H2, okay? But at anode, what happened at anode? Hydroxide negative ions and sulfate negative ions are attracted to anode, okay? So there is no halogen during electrolysis, so hydroxide discharged by oxidation process, where losing electrons during electrolysis and change into water and oxygen, okay? So the volume of hydrogen gas produced at cathode is twice the volume of oxygen produced at anode, okay? Example number 2. The electrolysis of dilute solution of sodium chloride. What happened? We have hydrogen positive ion, hydroxide negative ion resulted from water ionization, sodium positive ions and chlorine negative ions produced from ionization of sodium chloride, NaCl. At cathode, sodium positive ion and the hydrogen positive ions are attracted to cathode. Hydrogen ions only discharged because hydrogen is less reactive than sodium according to chemical activity series. So hydrogen reduced by gain electron and change into hydrogen gas, H2. Hydroxide negative ions and chlorine negative ions are attracted to anode, so where the chlorine is from halide, from halogen. So it discharged at anode by losing electrons and change into chlorine gas, and this is process known as oxidation. Okay. After that, we have the electrolysis of copper sulfate solution, once by using a graphite electrode and the other by using copper electrode. Okay. Let's start with electrolysis of copper sulfate by using graphite electrode. Water ionized, look at the figure in front of you, water ionized into hydrogen positive ion and hydroxide negative ions. Copper sulfate also in electrolytes ionized into copper positive ion and sulfate negative ions. Hydrogen and the copper are attracted to cathode, where copper is less reactive than hydrogen according to chemical activity series. So what happened? The copper gain electrons to each copper ion gain 2 electrons and reduced and change into copper metal. Okay, where the copper metal deposit on the electrode surface as we see. Okay. At anode, sulfate negative ions and hydroxide negative ions, all of them are attracted to anode. Okay. The hydroxide negative ion oxidized by losing electrons, so what happened? It produced water and oxygen. The evidence of evolved of oxygen gas during electrolysis, appearance of bubbles around the anode electrode. Okay. So example number 2, the electrolysis of copper sulfate, okay, but by using copper electrodes. In this case, we use copper electrodes instead of graphite electrodes. Okay, when copper electrodes are used in electrolysis of copper sulfate solution, the mass of the copper from the positive anode, okay, electrode should equal the mass of the copper gained or deposited on the negative cathodic electrode. Okay, and you can show this by weighing both electrodes at the start of the experiment. Okay, what happened? Positive ions, copper and hydrogen, are attracted to the negative electrode. What happened to the copper? Copper can gain electrons and change into copper metal. Okay, the copper metal can deposit on the electrode surface. But at anode, the negative ions, sulfate and hydroxide, are attracted to the positive anode electrode, but they don't change. Okay? Instead, the copper atoms that formed the anode electrode lose electron and oxidize it to copper positive ions. Okay? And this is process known as oxidation. So the copper ions will be formed, will be attracted to cathode electrode and reduced by gaining electron and change into copper metal and so on. Okay? Thank you for your good listening, grade 11, and goodbye.